Hey, 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 it's Dr. J, starting chapter 6 today. And you'll be happy to know that the last test is chapters 5 and 6 combined. Although I shouldn't call it the last test because there is also a final exam, which is the entire course. But the last, topical test, we're almost there. Yeah, we get through chapter 6 in a couple weeks. So that means you can see the light at the end of the tunnel, right? So I'll start off with 6.1. It's very common to just develop a good understanding of how percent works. And so percent literally translates into per 100. Yeah. Cent, 100, century, cien, centurion. I can't think of any other words. So we have percent means per 100. Yeah. So if I say something like, and the symbol, so per is divided by. Yeah. And we usually don't use the old-fashioned divided by symbol. We usually use the slash for divided by 100. And I really love this demonstration because we take this slash, and many, many years ago when people were writing in cursive, but with a quill or something, very common notation for percent was to put it like this. Yeah. In other words, omitting the 1. So the really old-timey, if you look at some, 1800s or maybe 1700s, things going back, to the Revolutionary War era or something, this may be how Benjamin Franklin might have written percent. Yeah. And then, over time, this symbol got morphed by taking one of these O's, they kind of look like O's, but they're actually zeros, and kind of bringing it up here and writing it this way. And so that's sort of the de-evolution of the percent symbol, or if you like, the evolution of the percent symbol. And so this is the percent symbol. It's a very common symbol. You've probably seen it quite a bit in your life. Okay, I'm overthinking it a little bit here. I just want it to look nice. There you go. So there's your percent symbol. And so when I say something like, 20%, let me say 23%, because I don't really want to do any reducing or anything right now. When I say something like 23%, this literally translates into 23 per 100, or 23 divided by 100. Yeah, these all mean the same thing. 23%, 23 per 100, or 23 out of 100, 23 divided by 100, or 23 100ths. So this is what we call percent form. This is what you'd call fraction form. Or you could say fractional form. And then finally, you could divide this, 23 divided by 100. We just went through an entire chapter on decimals, so I'm not going to relive that. I'm just going to assume that you know how to do that. 23 hundredths. And so this would be decimal form. So in this lecture, I will be going from percent to fraction, fraction to decimal, decimal to fraction, fraction to percent. And so you want to be able to move smoothly between the different forms. Okay? They all mean the same thing. Yeah? 23% means the same thing as 23 out of 100, or 23 hundredths, which means the same thing as 0.23. Okay, that's my introduction. Let's go ahead and just dive in and start doing some problems like you might see in the homework. So when a decimal has two decimal places, when a decimal has two decimal places, it's essentially a free answer. So if I say 0.15, and I want you to write this as a percent, it's essentially a free answer. Yeah. This already means 15 out of 100, so it already means 15%. So anytime there are two decimal places, you're essentially getting it for free. So 0.34 means 34/100ths, which already is a percent. If you don't have two decimal places, suppose you only have one decimal place, well, that's a tenth. You could easily convert a tenth into a hundredth by multiplying it by 10. So that is 60/100ths, which is 60%. So 0.6 or 6/10 is the same as 60%. Okay. And then if you have more than suppose you have more than two decimal places. This is 248 thousandths. Yeah. Thousandths. So that's not a percent. That's a per mil or per thousandth. Yeah, no, we don't really have a symbol for that. So what you'll do is divide both of these by 10. So that becomes 24.8 over 100, because you always want the denominator to be 100. That's what percent actually represents, per 100. And this is not per 100, this is per 1,000. So you just divide it by 10. That's 24.8, so that would be 24.8%. Okay. You probably remember the trick. There is a trick. I don't necessarily like this because when I'm going to show it to you, because I'm sure you've all seen it before and you're probably all going, wait a minute, I learned it a totally different way. The problem with the trick is it doesn't teach you or help you understand what it is that you're actually doing. It gives you the answer very quickly, but you end up leaving without really feeling any, understanding of it. And so the trick is to drop the zero, move the decimal two places, and put a percent sign. And that's sort of what we call the quick and easy. Yeah. It's fine. I mean, I'm not going to forbid anybody from using that quick and easy method. The problem is if you don't think about what you're doing, the quick and easy method can often cause problems later in life, right? So again, I'll show you it really quick. You drop the zero, you move it two places, and you add a percent sign. You drop the zero, you move it two places. If necessary, you add a zero and a percent sign. The quick and easy one really works pretty well for part D, because rarely ever would I know a student, even myself, that wants to do this dividing by 10 business here. So this trick works really well for this problem. You cross off the zero, you move the decimal two places, and then you add a percent sign, and that jumps you right to the answer a lot quicker. Okay. I'm not 100% against little tricks like that. I just think tricks are really not for kids. Tricks are for experts. And so when you become an expert, then you sort of get the benefit of knowing the quick trick. And if a problem is difficult, the trick doesn't really help you. But understanding that it's actually a fraction, all percents are technically fractions where you're dividing by 100, then you get a much more well-rounded understanding. Now remember, this is 6.1, so the problems will get more difficult as we move through chapter 6. And we'll probably have some word problems. I don't think there's any geometry in chapter 6. I mean, don't quote me on that yet, but my gut instinct tells me there's probably no geometry. All right, unless I wanted to make up some torturous percentages geometry problem. Write each percent as a decimal. All right. So this time, write each percent as a decimal. Now again, there's a trick, right? And you probably remember it. Drop the percentage sign, move the decimal 2 places, right? I'm not going to show you the trick quite yet. I'm going to teach you the understanding, because that's what this is about, understanding percent. So 45% literally means 45 out of 100, or 45 hundredths, which then translates to the decimal 0.45. All right, do that 100 times, and then you can learn the trick. The trick is to cross off the percentage sign, move the decimal 2 places to the left, and add a 0. Essentially reversing the trick that I showed you in the last section. So 3% means 3 out of 100. Which means 3 100ths, or 3 hundredths. All right. 1.2%. Well, that's 1.2 out of 100. We're going to multiply this by 10. I guess I should use parentheses for multiplying in this section, right? I don't want to, I know maybe in the last one it was confusing what a dot for multiply and a dot for decimal. This is a decimal dot. So 1.2 times 10 is 12. And then 100 times 10 is 1,000. And so the decimal is 12 thousandths. So 12 thousandths is 0.012. Remember, tenths, hundredths, thousandths. So you put the 2 in the thousandths place. Okay. 358% means 358 over 100, which is 3.58. It's 3 and 58 hundredths. That's the way you would say this. 3 and 58 hundredths. Remember, the decimal point is read as the word and. Yeah. Okay. I would make a little mental note here. Whenever a percentage is more than 100, if it's more than 100%, then you're always going to have a whole part. So in this case, the whole part is 3. Write each fraction as a percent. Round to the nearest tenth of 1%. If necessary. It's not always going to be necessary, but just in case. I realized that as soon as I wrote 2/3, I was going to need that. I guess I'll just do 3 parts for this one. All right. So there's sort of the old school way to do it, which is to divide this. Make sure you divide it the proper way. So 8 goes into 3. I often get these reversed on accident. So make sure the numerator is the dividend and the denominator is the divisor. All right, 8 does not go into 3. So 0 times. 8 goes into 30 3 times. That's 24. 8 goes into 60. How many times? 7 times. 7 times 8 is 56. 8 goes into 45 times. So that's 375 over 1,000, which is 37.5 over 100, which is 37.5%. Again, I didn't really show the math here, but I just divided numerator and denominator by 10 so that the denominator becomes 100. And then once it becomes 100, then you can say percent. All right, that's sort of the old school way to do it. The new school way to do it is with a calculator. All right. I know that you're going to use a calculator. I mean, you might not always use a calculator. I hope. You know, this is the kind of thing I lay in bed at night going, oh, God, I hope they're not using calculators on every problem. You use the calculator sparingly, okay? So 2 divided by 3, 2/3. You know what? As soon as you do it, you're going to go, wait a minute, I didn't need to do that. Yeah, 666666666. You already knew that, right? In fact, oftentimes when people pick up a calculator, the calculator is just telling them something they already know. I mean, there's some exceptions. There might be some weird numbers that you just never learned growing up or whatever. But most of the stuff you ever needed to know, you already know it. Right? It might have been a while, but you know it. All right, now here's the trick with this. When I say round to the nearest tenth of a percent, all right, you want to keep 4 decimal places. That's important. Don't go to 3 or 2 or 1 because oftentimes you memorize tenth. A tenth is 1 decimal place, and as soon as you do that, you're going to get these wrong. All right. So a tenth of 1% is 4 decimal places, and then the last decimal place is the dictator. And the second to last one is the tenth of 1%. All right. So that's going to be 0.66. The dictator is bigger than 5. So we're going to add 1 to the 6, and that's going to be 667. Okay, and then we're going to write that as 66.7%. Just like we did up here, see? 3 decimal places is 0.1%. I would just memorize that. 3 decimal places comes out to be 0.1%. Okay. So 1/20th, 1 divided by 20. You probably already know that. That's a nickel. Yeah, 0.05. I mean, if you have to use the calculator, go for it. 1 divided by 20. And as soon as you do it, you're going to go, oh, yeah. That's what a nickel is. A nickel is a 20th. Yeah. We don't like to say a 20th. And so we say a nickel. It's just a slang term for a 20th. Yeah. A dime is a 10th. Yeah. And a quarter is a 4th, and a half is a half, and you all know those. Yeah, this is one that a lot of people don't learn growing up, that another word for a nickel is a 20th, 1 out of 20. Okay, so it is 0.05, which is 5/100ths. That's already a percent, so you don't need a decimal point for that one. It's just 5%. So you don't always have to round. Okay, the most common rounding, if you have to round, is 0.1%. There might be some problems. I haven't got there yet, but there might be some problems where we round in a different way. I mean, other than 1/10. We might do some other types of rounding. Oh, that was already 4, wasn't it? So this is 5. So write each percent as a fraction, reduced to lowest terms, also known as simplifying. Okay, write each percent as a fraction, reduced to lowest terms. So 36%. That's 36/100ths. Now you can't use your calculator, because if you do the calculator, it's just going to turn it right back into a decimal, and it's not going to give you a fraction. Right? They do sell some really fancy calculators nowadays that do fractions. I wouldn't run out and buy one right away. I mean, you might make an investment in one if you're going to be doing this for a while. But I honestly, I used the most simple calculator that I could buy. This was just a couple dollars. And if it breaks, it's solar powered. I don't have to worry about batteries or anything like that. And I can always buy another one if I lose. It's like my 3rd one I've gone through. So 36/100ths. We're going to review fractions here. 36 is what? 2 times 18. 100 is 2 times 50. I could keep going. 18 is 2 times 9. Not 2.9, but 2 times 9. Should be very careful there. And 50 is 2 times 25. I guess if I were clever, I could have just done all that at once, but I wanted to show you how you can just do it in small batches. Usually it's dividing by 2, Sometimes it's dividing by 5 or 3 or some other number, but the most common is probably 2. 9/25. Stop when you have no more common factors. You could try to keep going. The numerator is 3 times 3 and the denominator is 5 times 5, but if they don't have anything in common, you could stop. So 8% is 8 over 100. 8 is 4 times 2. 100 is 50 times 2. I guess I could keep going. 4 is 2 times 2 again. And I wish I just would have done, on second thought, I should have just done this. Whatever, I already did it. I should have just done 25 right away, right? I just saw it now. I could have done 25 times 4, and then I would have got it in one step. It's okay. It doesn't, as long as you get it, it doesn't matter how many steps you take. It's 2/25. 100 is only divisible by 2, 4, and 5, and 25. Oh, and 50, right? So, I mean, you don't really get a lot of reduction here. And you'll see this happens quite a bit. 0.2%. Now, you got to be careful with this one. I mean, this is the whole reason why I don't use the dropping the sign and moving the decimal trick, because on a problem like this, it totally screws you up. Yeah, it might work on some of these other ones, but, you know, I just go to the definition. The definition of percent means divided by 100. Yeah, and if you live with that definition, you can survive a long way. All right, you'll live a much longer mathematical life. I need to have this as a fraction, so I'm going to multiply this by 10 because I don't want to have any decimals in my final answer. So that's going to be 2 thousandths. 2 over 1,000, which is 1 times 2, and 500 times 2. And so reduced fraction is 1/500th. Okay, 0.2%. You might want to go the other way. There we go. I wish I could just make it do that every time. So you might want to go the other way. Write each fraction as a percent. And again, round to the nearest tenth. Now, when I say tenth, I mean tenth of 1% is what I mean. Yeah. So how about this? Okay. I know that for dividing by 7, remember in the chapter on fractions and decimals, the section on fraction and decimals, 7 was a very long division problem. So this is a perfect use of a calculator. 2/7 is a very long decimal. And so I'm not going to write this out by hand. Well, I'm going to write out the result by hand, but I'm not going to calculate it by hand. 285714, 285714. It's going to repeat, 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 repeat. So remember, you're rounding to the nearest tenth, so you want 4 decimal places. I really did this problem already. I'm just giving you another version of it. So you've got 0.2857. The dictator will be the 7. That is greater than 5, so we're going to plus 1 to the 5. So we're going to get 0.286. Yeah, and then cross all those guys out. And then now turn it into a percent. That's going to be 28.6%. 4/5. 4/5 is one that you know by heart. It's 0.8. Yeah, I hope you know it by heart. Remember, 1/5 is 0.2. Yeah, so 2/5 is 0.4. So 3/5 is 0.6 or 0.6. And then 4/5 is 0.8. Okay. So that's 8/10. Yeah. Which is 80/100ths or 80%. No need to round on that one. And again, if you remember, you could just move the decimal 2 places and jump all the way to here. Or you could go 2 times 4 is 8, and 2 times 5 is 10, and then that jumps you right to here. So there's lots of ways to jump. Okay. I like this one to do this one a little bit differently. Instead of going 8 divided by 25, which is what you could do on the calculator, right? You could just do it on the calculator. This one has a neat trick. 25 goes into 100 4 times, so I'm just going to multiply it by 4, and I get 32/100ths. Right. And then that's automatically 32%. This is sort of the mental math way to do it. So if you're driving or you're walking or you're at the store and you try to do some mental math calculation without taking out your phone, without using decimals, you just, 25 goes into 100 4 times, so I can just multiply it by 4 and I immediately know it's 32%. I guess I could have done that trick here, right? 5 goes into 120 times, so I multiply the top and bottom by 20, and that jumps me all the way to here. Yeah, 4 times 20 is 80, and 20 times 5 is 100. So, the ways you can go. There's so many ways to go. All right, the next one I'm going to do is, I call it like a potpourri. It's just sort of a mix of all the different So just convert each value into a percent. So these are values, real numbers, and we're going to turn them into percents. Okay. So 5/4. 5/4. Well, 5/4 is 1.25. Yeah, $1.25. I actually read this as 5 quarters. Yeah, 5 quarters. 5 quarters, $1.25. Or you could take out your calculator and 5 divided by 4, either way. Okay? I hope that you have a good mental sense of how that works. So $1.25 is 125 hundredths, which is 125%. So if a number is larger than 1, then the percentage will be larger than 100. $6.1, that's 61 tenths. 6.1, it's only got 1 decimal place. So that's a tenth. I want hundredths, so I'm going to multiply by 10. I guess I'm using parentheses for multiplying. I'm not really very consistent with that. As long as it's not causing an error, then you can do it either way. 61 times 10 is 610. Over 100, 610%. Okay. I think we've done this one before, but we did it the other way. So I kind of think I know what it is. I think it's 1 out of 50, but let's see. It might be 1 out of 500 or something. I don't know. Yeah, I think it is 500. We'll see. So it's 2 thousandths. That's 3 decimal places. Yeah, 2 1,000ths. So we're going to divide this by 10 because we want hundredths. When you divide 2 divided by 10, you get 0.2. So that is 0.2%. 0.2%. Also known as a fifth. Yeah, or 1/5%. It just says convert it to a percent, so this one actually has 2 correct answers. You could say 0.2%, or you could remember that 0.2 is a fifth, so it's a fifth of a percent. Yeah. Remember my guess? My guess was that it was a 50th, which was wrong. Yeah. A 50th is actually 2%. This is 0.2%, so it's a fifth of a percent. Okay, I think I just have one more of these potpourri, sort of mixed examples. And then I got a summary that I hopefully will help you. When we're doing word problems, which we will eventually get to in Chapter 6, all of the word problems are solved using decimals. So I will often give you a problem involving percents, but you cannot, or typically cannot, solve them outright using percents. You have to convert them into decimals, solve the problem, and then sometimes even convert it back to percent, depending on what the question is asking. So taking a percent, your immediate instinct when you see it should be to think of it as a decimal immediately. So there's lots of different percents that we would turn into decimals. So there are lots of word problems that are going to come up in the chapter where I say 0.75%, or 0.75%, or 502%, or 0.6%. And you cannot actually keep these numbers in this form. You have to change them into decimals before you can actually solve the problem. All right. So this is just an exercise in how to change them into decimals very quickly. All right. Or maybe not quickly, but efficiently, so that you get the right answer every time. All right, so 3/4. 3/4 means 75 cents. Yeah. So first, turn the 3/4 into 75 cents. Yeah, and you can do that on your calculator if you need to. I'm trying to avoid it if it's one that we know. Now you want to turn it into a fraction. Okay. And then remember the rule for dividing by 100? I hope you remember. If not, you're going to get a quick refresher. To divide by 100, you move the decimal 2 more places. So you drop the 100 and you move it 2 more places to the left and add a couple zeros. So you get 0.0075. Right? I don't want to keep it as a percent. I don't want to keep the 100 in the bottom. I got to get rid of the 100 in the bottom because I'm trying to turn it into a decimal. All right, 502%. Well, 502 is already a decimal. It's just a decimal with the decimal point right there. So there's an invisible decimal point. Every whole number has an invisible decimal point. Right at its far right. Okay. So again, we're dividing by 100. So we're going to drop the 100 and move the decimal 2 places to the left. Which is again why I have, resisted to give you all of these quick little tricks that you learned when you were little, because when you learn a trick when you're 10 or 12 years old and it says move it to the left or move it to the right, by the time you get to be 20 years old, you're like, well, I don't remember. That was 10 years ago. Do I move it to the left? Do I move it to the right? When you're dividing, you move to the left. When you're multiplying, you move to the right. I mean, I've said it and I'll keep saying it, but it is very, very common, not just among math students, but just among human beings in general, to mix up, do I go left or do I go right? I mean, it's not weird. It just means you're human, right? You get things backwards all the time. And so this is a way of by understanding the concept, you can kind of go, well, if I understand the concept, then I'm less likely to make a directional mistake. What breaks my heart is when people don't pass this class, not because of their intelligence, it's not because of their will or their, discipline, or you're doing everything right, but you just make directional up, down, left, right types of mistakes, and it causes you to have to, that's the kind of thing I lose sleep at night over. So help me out. So 0.6% is 0.6 over 100. Okay, it's a lot like this one up here. 0.6 over 100. So I'm going to drop the 100, move the decimal 2 places to the left, and then add a couple zeros if necessary. Notice in part B, I didn't have to add any zeros, but this time I do. So I get 0.006. All right, that pretty much does it. Before I close off this video, I want to just say that we're going to be using percent so often in so many different ways in Chapter 6 that it really is to your advantage to have good mental math skills. So there are certain percents, fractions, here let's say decimal first, and fractions. And again, I'm done with all the actual homework examples and stuff. This is just so that as you're going through Chapter 6, this is just a doctor recommendation, If you have good mental math skills, you will have an advantage over every other student not just in this class, but in the entire college. So when you go on to your intermediate algebra and your college algebra and such, you will be able to just snap through problems that other people are panicking and freaking out and using their calculator, when you could just sit there and very calmly go, I know these, right? There are certain percentages that you should just know by heart. Yeah. 1%. Yeah. 1%. It comes up all the time. Yeah. As a decimal, that is 0.01. You don't need to use a calculator. You don't need to show a bunch of work. You can just read this and you know that it's that. Yeah. And then as a fraction, it's 1/100th. Okay. 2%. That's 1/50th. I'm going to skip 3%. We're going to go to 4%. That's 1/25th. Yeah. Not a quarter, though. It's not a quarter. That's called a 25th. Yeah. It's 4%. It's 4 cents if we're talking about money. I skipped 3. 3 is just 3/100ths, but it's not reducible, so I left it out. I'm doing the ones that are reducible, or at least I think they're nicely reducible. 5%. 0.5. That's a 20th. 10%. 0.1. Some people put the invisible 0 here. I'll leave that to you if you like. I typically don't. I just remember 10% is 0.1 or 1/10. You do not need the extra 0. It's not going to help. All right? It's not going to make the problem any easier. So 1/10. 20%. 0.2. 20%. That's 1/5. 1/5. 20%. A fifth. Two dimes. Yeah. It'd be really cool if there was actually a coin that was worth exactly 20 cents. But the U.S. Mint, I think, got rid of them in the 1800s. There was a brief period of time where there was a 20-cent coin. It didn't last very long. Okay, I know this. If you're already ready to do your homework, you can go ahead. This is just my recommendation to memorize all of these so that you don't need to use a calculator. I will do some problems in the next couple sections where I refer to this, and I'm not going to write this list out again. So if you just want to just write it down one time and you'll have it. 25% is a quarter. 1/4. 50%. Actually, let's go to 40. I like 40%. 40%. That's 0.4. That's 2/5. 60%. 0.6. That's 3/5. 80%. That's 0.8. That's 4/5. This is very useful, not even just in my class, but just in life. I mean, you're going to go, shopping, and you're going to see things that are on sale for a particular percentage. You're going to read books and word problems and things not even in my class, but in your science classes, and things that list things in percent form, or sometimes they list them in fraction form, or sometimes they list them in decimal form. So not have to calculate every 10 seconds of your life, to be able to just look at it and know it, is pretty good thing to know how to do. A couple more. 50. Did I do 50%? I didn't put it in here. So 50% is 0.5, which is 1/2. So a lot of these you probably already know. I hope you do. 75%, 0.75, 3/4. 75 cents, 3/4. 100% is 1. Yeah. Now you could say 1.0, and you can say 1/1 if you really like. I don't. I just say 1. Yeah. 100% is 1. It doesn't matter whether you write 1/1 or 1.0 or 1.0, it still means 1. 150%, 1.5, that's 3/2. 200% is 2, or 2.0. Yeah, or 2 2s, or 2 1s, which is just equal to 2. Okay, that's really about it. I hope you are introduced. That was my goal. My goal really was not to do any of the real complicated problems in this section. I kind of combined the very end of Chapter 5 and the very beginning of Chapter 6 into one module this week. So go ahead and get that going, and then in the next module I will start throwing it out there. We'll actually start using all of this stuff to solve some real world problems. But until then, this is Dr. Jordan. I'll see you on the internet.